So this video is to summarize our gas laws, to talk about our gas theories, but before we can even do that, we have to talk about what is the difference between a theory and a law. So that's where we're going to start. So theories and laws have both similarities and differences. Laws are considered descriptive, whereas theories are considered explanatory. Laws tell you what's going on, whereas theories tell you the why. Both laws and theories are based on lots of evidence. Our laws, though, are made from observations. So we collect evidence, we observe what's going on, we develop our descriptive laws about what's going on. Whereas theory, since we're trying to explain, based on our evidence, we infer why we observe what's going on. And then both theories and laws can change with new evidence. Neither of them are static. They're both dynamic, they can change, both are supported by lots of evidence. One doesn't necessarily, just because it's a law, doesn't mean it's written in stone, it's not fact. Those aren't the same things. Both laws and theories can be used to become hypotheses. There's also a gas theory that helps to describe what's going on. So we can infer from our evidence, because we can observe the effects of pressure and volume, pressure and the number of particles, and pressure and temperature. But we have to be able to explain why. And our gas theory is what helps us explain why. And our theory has a particular name. It's called Kinetic Molecular Theory, or you'll see it abbreviated KMT. So Kinetic Molecular Theory, and it has 5 pieces to it. The first one says that our particles of gas must move in straight lines and obey Newton's laws. So they're not moving in curvy lines, they're moving directly from point A to point B until they hit something else. Number 2, it says that our particles have essentially no volume. We treat them as if they're points. Number 3, our collisions are perfectly elastic. So we talked a lot about particles colliding with each other and with the walls of containers. Those collisions, we assume, are perfectly elastic. That means that there is no energy lost or gained during the collisions. We also assume that there are no attractive or repulsive forces between particles of gas. So when they collide, there's nothing there holding them together. They immediately bounce right off, and perfectly elastic because we don't want to lose any energy. And then lastly, we say that our speed is related to temperature. There's a formula for that, but it's complicated, involves constants. We're not going to be concerned about the actual formula for the average speed of a gas particle. We just need to know that it is related to temperature. So our pieces of our gas theory explain why we observe what we observe in our gas laws. So you need to know the 5 pieces of kinetic molecular theory. We've talked about most of these already. Now we're just giving them a fancy name and we're lumping them all together. We talked about the attractive and repulsive forces when we talked about gases as a state of matter. We talked about how they have to collide perfectly and don't gain or lose energy. We already related speed of the particles to the temperature because we know that when things heat up, they move faster. That's how we get through different changes in state. And then we're just putting some technicalities on it that they move in straight lines.